In this program, we'll use the turn knob to control how long the delay is between blinks of an LED. In the void setup function, use the pin mode function with the arguments A2 and input to set up your turn knob. The turn knob is going to be plugged into the smaller block of ports at the bottom of MakerBoard. Make sure the center pin of the turn knob is in port A2. And then the outside pins can be in either plus or minus. The turn knob is reversible as long as you've got that center pin correct. Our second pin mode function has the arguments to and output. This is for an LED. Within the void loop, we're going to create a variable. This int means this variable is an integer type, meaning it's a whole number with no decimals. Next is the name of the variable. I named it wait because this variable value is going to be inserted inside a delay. So wait is a very clear and easy name for this variable. After an equal sign, we set the starting value of the variable. This is analog read of A2. So this is going to take the reading from the turn knob and use that as the variable value. Because we're creating the variable inside the void loop, the variable value is going to get updated every single time the loop runs. The turn knob can send in signals from 0 to 1023. So that's the range that wait can have. If we wanted to change the range that wait could have, we could do something like times 2 to double the range, or times 10 to make it 10 times greater. You could also divide the range or do any math you want on this variable. But if we have it as analog read A2, the wait variable can have a range from 0 to 1023. The next line in this program is a digital write function with the arguments to and high. Next we have a delay with the argument wait. That wait is going to use the variable value, and the variable value comes from the analog read of A2. So after the program delays for wait amount of time, it's going to reach line 13 and run the digital write to, low function, turning off the LED plugged into port 2. Next, you're going to use delay again with an argument of wait. So again, we're using this analog reading we took at the top of the loop and using it for the number value in the delay function. After this delay has completed, the code reaches the end of the void loop and jumps back up. At this point, it's going to update the variable wait. It's going to take another reading from A2 and assign that reading value to the word wait. So keep in mind as you're playing with this, if you turn the knob all the way to one side, and let's say that your wait is 1023. Once your LED turns on, you've got to wait 1023 milliseconds. Then the LED turns off, and you've got to wait 1023 milliseconds before you can get another update to your variable. So in this case, the knob might not be really responsive to you twisting it, because once you've set that variable value on line 9, the rest of the code has to run before that wait is updated. This is a little bit different than some of the past projects which have had almost no delays in them at all, because there the variables were updating hundreds or thousands of times per second. Here, the variable could update as slowly as once every 2 seconds.